In the last video, I started introducing the intuition for the Laplacian operator in the context of the function with this graph and with the gradient field pictured below it. And here I'd like to go through the computation involved in that. So the function that I had there was defined, it's a two-variable function, and it's defined as f of xy is equal to 3 plus the cosine of x divided by 2 multiplied by the sine of y divided by 2, And then the Laplacian, which we define with this right side up triangle, is an operator of f, and it's defined to be the divergence, so kind of this nabla dot, times the gradient, which is just nabla, of f. So two different things going on. It's kind of like a second derivative. And the first thing we need to do is take the gradient of f. And the way we do that, we kind of imagine expanding this upside down triangle as a vector full of partial differential operators, partial x and partial y. And with the gradient, you just kind of imagine multiplying that by the function. So if you imagine multiplying that by the function, what it looks like is just a vector full of partial derivatives. You're taking the partial of f with respect to x and the partial of f with respect to y. Those are the two different components of this vector-valued function that is the gradient. And in our specific example, when we take the partial derivative of f with respect to x, what we get, so we look over here, 3 just looks like a constant, so nothing happens. Cosine of x halves, the derivative of that with respect to x, we kind of take out that 1/2. So 1/2, and the derivative of cosine is negative sine, so that's negative sine of x over 2. And sine of y over 2, well, y just looks like a constant, so sine of y over 2 is just some other constant. So in our derivative, we just keep that constant in there, that sine of y over 2. And then for the second component, the partial derivative of f with respect to y, 3 still looks like a constant because it is a constant. Now cosine of x over 2 looks like a constant because as far as y is concerned, x is a constant, so cosine of x is a constant. But then the sine of y has a derivative of cosine, and we also take out that 1/2. So you take out that 1/2 when you take the derivative of the inside, and then the derivative of the outside is cosine of whatever was in there. So in this case, y over 2. And we're multiplying it by that original constant, cosine of x over 2. So still we have our cosine of x over 2, since it was a constant times a certain variable thing, x over 2. So that's the gradient. And then the next step here is to take the divergence of that. So with the divergence, we're going to imagine taking that del operator and dot producting with this guy. So if I scroll down to give some room here, we're going to take that vector that's kind of the same vector, the partial x, and I say vector, but vector-ish thing, partial y. And now we're going to take the dot product with this entire guy. So I'll go ahead and just copy it over. Just kind of copy it over here. And let's see. So we'll need a little bit more room to evaluate this. So here, when you imagine taking the dot product, you kind of multiply these top components together. So we're taking the partial derivative with respect to x of this whole guy. And when you do that, what you get, you still have that 1/2, and then the derivative of negative sine of x over 2. So that 1/2 gets pulled out when you're kind of taking the derivative of the inside. And the derivative of negative sine is negative cosine. So negative cosine of that stuff on the inside, that x over 2. And of course, we still multiply it by this. This looks like a constant, the sine of y over 2, and we multiply by that. Sine of y over 2. And then we add that, because it's kind of like a dot product, you add that to what it looks like when you multiply these next two components. So we're going to add, and you have that 1/2, and then cosine of y over 2. When we differentiate that, you also pull out the 1/2. So again, you have that pulled out 1/2. And the derivative of cosine is negative sine. So now we're taking negative sine of, and then that stuff on the inside, y over 2. And we continue multiplying by the constant. As far as y is concerned, cosine of x over 2 is a constant. So we multiply it by that, cosine of x over 2. And then that is the divergence of that gradient field. So the divergence of the gradient of our original function gives us the Laplacian. And in fact, we could simplify this further because both of these terms kind of look identical. But the main point of this video is kind of how you go through that process, where you imagine taking the gradient of your function and then the divergence of that, and that's what the Laplacian is. See you next video.